Good morning. This is Karen from DOER. We're going to be starting the live presentation shortly. We're just waiting for see if a few more attendees log. But let me introduce our Green Communities Deputy Director, Joanne Becerra, who runs these for our Green Communities Division. Joanne?
Good morning, everyone. Thank you for tuning in, and as Karen mentioned, we will just wait a couple more minutes for folks to log in, so hang on and we will start the webinar shortly. Okay, I think we'll get started right now. We seem to have a good amount of folks registered at this point. And I just have a few introductory slides anyway. So first, I want to welcome you all to our virtual webinar. We are all sitting in different rooms in different parts of the state. So if there are any technical difficulties, please bear with us. Next slide, Karen. There we go. So a little bit about the Green Communities Division. Those of you who aren't familiar with us, we run a variety of programs. Our flagship program is the Green Communities Designation and Grant Program. But we also offer other resources to other public entities, including the Mass Energy Insight Energy Tracking and Analysis Tool. We provide technical assistance for municipal energy. And again, you don't have to be a green community to access these grants. We have a website that has all sorts of tools and resources. You can see the link on your screen. And we also have email updates and e-blasts. So if you did not hear about this webinar through an e-blast, you will want to sign up for these e-blasts. Next slide, please. I would be remiss if I didn't mention our awesome field staff. Our regional coordinators are scattered throughout the state to provide on-the-ground assistance to cities and towns on anything energy related. We have Mark Rubinski. He works out of the Springfield office when he's not under quarantine. Neil Duffy is in the Northeast region. Kelly Brown is in the Worcester office. And Lisa Sullivan serves our Southeastern and Cape and the Islands. So please make a note of their emails and please reach out to them if you haven't already. Next slide, please. A few upcoming events. As you can imagine, everybody's schedules and events have been sort of upheavaled. However, I do want to make note that we have extended our Green Communities Competitive Grant deadline to May 1st. Originally it was March 27th, so we did add about 5 weeks to that deadline. So hopefully those of you that are considering to apply for that grant know about this deadline. And then we do have a couple of events that are scheduled right now to be live, but most likely they may occur online. And this is a heat pump and VRF training. We're working with the UMass Clean Energy Extension as well as manufacturers representatives from the heat pump industry to provide training specifically for municipal staff and volunteers. Next slide, please. The previous slide had mentioned that this webinar is being recorded and will be posted online. There we go. And then if you find a slide that you want to save immediately, there is a camera icon on the top right-hand side of your screen, so you can take a screenshot of a particular slide. And then use the Q&A icon on your screen as well to type in questions. There will be time afterwards for a Q&A, and any questions we can't answer immediately or we run out of time for, we will include in the Q&A, and all those questions will be added to the webinar link. And now I would like to introduce Paul Ormond. He's an energy engineer in our energy efficiency division here at DOER, and he's going to tell us all about Passive House. So Paul, take it away.
Hello, can you hear me okay, Joanne?
I can.
Great, fantastic. How's everyone doing? I see 58 participants, so really pleased with the turnout. Thank you so much for joining, and hope everyone is surviving well during these weird times. So I work in the DOER, and my role there is energy engineer. So I work in building science kind of stuff, HVAC, renewables, and so this is a very brief presentation on Passive House. A quick explanation of what Passive House is and also why it's important to the state of Massachusetts and helping us achieve our greenhouse gas goals under the Global Warming Solutions Act. So this is, I think it's about 20 slides, so it's kind of snappy. So what I thought we'd do is go through the entire presentation, and then you can ask questions through your chat or dialog box type of thing along the way, and then we'll address all the questions at the end, and then we can go back to slides. So I just wanted to point out all these photos here are pictures of projects that are built or being built now that are Passive House that are in our region. And so for example, this top left one, can you see, Joanne, can you see my mouse turning around, the little arrow?
No.
Oh, okay, all right, so I'll know to pay attention to that. Okay, so the top left picture is a Montessori school in Hollis, New Hampshire. That's a Passive House. The middle top is an apartment building in South Boston. That's a Passive House project. The top right is the 115 Winthrop Square office tower in downtown Boston. That's Passive House. That's in construction now. And what is just starting construction right now too is the bottom left, which is the Bunker Hill project. This is about 3,000 Passive House units. So in Mass, we are just extremely excited that Massachusetts has become a cool go-to place for Passive House in North America. And we're super excited to be hosting, especially the Bunker Hill project. This is going to be the largest Passive House project in North America by far, the one on the bottom left. And the top right, the Winthrop Square, will be the largest office tower Passive House in the world. So we're on the map when it comes to Passive House, which is exciting because it barely existed in Massachusetts not that long ago. Want to go to the next slide? Oh yeah, let's get a poll here. So we wanted to get a sense of who you are. So if you can select one: architect, energy, professional, facilities, school employee, or volunteer. And Karen, are you seeing the poll numbers come in?
Yeah, we're about 81% voted, so I was just waiting.
Okay, great. For
Looks
all of you
like
out there,
that's where we're gonna.
just so give Karen a shout out, she does a ton of work to organize these. So thank you, Karen, for getting this together.
Thank you guys. So we have the results with 81% voting. We have 30 are municipal volunteer or other, 25% are municipal school employee, 4% staff, 19% in energy professional, and 15% in architect.
Oh, that's a great mix. I love it. You know, I just wanted to say that I've observed how people that get involved in green communities, whether they're volunteers or whether they're people that work for the municipalities, I've observed how much they're able to influence things that happen in their town, not just the municipal buildings, but also all development. So I just wanted to say how much we appreciate everyone's work to advance all of our kind of common goals. Let's go to the next slide. I wasn't sure, are we on the next slide? I'm just still seeing the poll, or am I stuck?
I have, can you find a passive house? Joanne, do you have that one?
I do not. I also just see the poll. Oh, there
okay.
we go.
There we go.
All
Thank
set.
you very much. Yep. Yeah, just so you know, everyone, we're not in the same room, so we're kind of doing this all remotely. All right, so we'll do Where's Waldo? So one of these townhouses is a passive house. It was a retrofit. This is in New York City, and you can't tell that it's passive house. It's not some weird building. It works for all building types and all retrofits. So let's take a look at the next slide, and we'll see which one is passive house will become immediately obvious. And you can see this is a picture with the infrared camera in the winter time. So you can see the building there that's cool blue, that's the passive house. And everything else is leaking heat left and right. You can see this just like we're basically, our utilities are heating the outside. We're leaving the barn door open. But in a passive house, we close the door because we have a good envelope. Let's go to the next slide. So this is the principles of passive house. This is why it works. So the first thing that we do is we take advantage of solar gain. Now I just want to point out, this is different than if you all grew up in the 70s and 80s like I did. Remember there was solar homes? Well, passive house is not that. Solar homes are totally different things. Passive house does take advantage of solar gains, but you don't have to have a particular building orientation or huge windows, that kind of thing. I just want to point that out. You can make it normal looking and you can site it anywhere. Passive houses are built in all climates, whether there's sun or not, but we do take advantage of solar gain when it's available. The second is the envelope itself. So specifically, it doesn't necessarily mean super insulation. It's more insulation than code, that's for sure. But it generally means continuous insulation, addressing thermal bridges, which is like metal and things that can bring heat in from the outside to the inside in the summer and vice versa in the winter. But also addressing infiltration, which is number 4. And as part of the envelope too, of course, it means quality windows. And then finally, energy recovery. People are always surprised to learn that passive house projects have more outside air in them than code buildings. So they're more ventilated because they have active energy recovery systems. Code buildings do not necessarily have that. And then increasingly, people are seeing the benefits of external shading, especially in a setting like a commercial building or an office passive house. So those are the 6 principles. Why don't you go to the next slide? So just some quick photos of what these look like when you're building them. I just want to point out, you can see the kind of shelves for the windows that will be installed inside this wall. And where you see that zip wall, you can see all the taping and such. That is making sure that this building is going to have a low infiltration rate. And then the blue stuff they're installing around those window boxes, that's the continuous insulation. That's kind of the key to passive house. low infiltration, and continuous insulation. Let's go to the next slide. All passive houses are tested for infiltration limits, that they have to be below a certain limit. And it doesn't matter if you're a single family home or a 30-story, 1 Winthrop Square office tower. Every last square foot of passive house certified buildings are air infiltration tested. So you do a blower door test on buildings of all sizes. And so they do have like massive commercial versions of this for big commercial projects. The air infiltration in passive house is like 10 times smaller than a code house. So it's way, way down there. Why don't you go to the next slide? Just another quick cross section showing kind of the key features again. That kind of light blue strip that's just to the inboard of the cladding, that is the continuous insulation. That's the key piece of the insulation that makes passive house work. Next slide. The windows themselves are a big part of passive house performance. So the windows have to be thermally broken. And what that means is that on the inside of the wood or metal frames, you have a piece of rubber or gasket that disconnects the metal or wood on the outboard side of the window and the inboard side of the window. And that's, in this case, you can see the orthogonal view here, the green. That's what that green is. So at no point in these windows is there a piece of metal that extends from inside to outside. Now, if you get a non-thermally broken window, just go down to Lowe's and get a window, they have nothing but metal and wood that goes from inside to outside. They're thermal bridges galore. So passive house windows are different than that. They have these thermal broken element, and that's what makes them perform well. And they're not necessarily triple paned. Again, it's not necessarily, passive houses aren't necessarily super insulated. What they are is continuous insulated, and they address thermal bridging. So I just want to point that out. I want to go to the next slide. So once we have a quality envelope, something magical happens, and that is that the HVAC systems can be radically simplified. So if you look back at the progress we made in the 20th century with the way we do buildings, it's all about condensing boilers and efficiencies of equipment and more equipment and more equipment and more equipment to try to like extract and best use BTUs. But what passive house is actually takes it in a different direction. And what it does is it addresses the envelope first and makes sure that we don't lose any heat or cool, if you will, from our envelope. And then once we do that, we find that we actually don't need that much HVAC system. It's we can simplify it significantly. Would you go to the next slide? So just linking back to why passive house is important to Massachusetts. So Massachusetts, as you're probably aware, needs to meet certain emissions reductions on a statewide level to achieve Global Warming Solutions Act objectives. So that's a number of buckets, right? So starting from left. So passive house uses way less energy. So that's kind of obvious. That's the first one. But the other thing that passive house does is that the peak loads of the buildings are way smaller. In fact, you can make the peak load 0 on a passive house because you can turn off the heating cooling systems during peak times because the building can easily ride through any peaks. And so when we look at global warming solutions, we have to address peaks. Passive house addresses that. The middle one is hugely important. Passive house makes it very easy to electrify space heating. One of the challenges with heat pumps VRF is that it can get a little complicated. It can be a little expensive, but that's when you're doing a code building because you have to distribute it everywhere. But a passive house, I'll show you some photos of this. They don't have to do that. It makes electrification simple. Resilience, something you might be interested in. Imagine you have a school, police station, fire station, any sort of public gathering place, nursing home, elderly housing, any apartment building. if these buildings lose heat or cool or power, they stay warm or cool. They stay fine on the inside. Way more resilient than anything else you can get out there. And finally, it's just way better experience. You can sit next to a window in a passive house office building or whatever. It's totally comfortable. Let's go to the next slide. It's an unfortunate thing that it's the word house is in the word passive house, and it's kind of just a kind of vestige of its evolution. But passive house can be done with any building of any size at any retrofit. So just want to make that clear. There are some places on Earth now that are making passive house code. So for example, Brussels, Belgium, all buildings are passive house, period. I find this is like interesting thing for me because my grandparents came from Brussels. So maybe this is like a weird fate on my part to be involved in this now. So I thought that was cool. Why don't you go to the next slide? So here's the energy performance of a passive house. This is a multifamily. A code multifamily would have an energy use intensity of kBTUs per square foot per year of about 40. That would be actually a really good constructed code building. It's not uncommon to see things actually much worse than that even still. But even if you built a decent building to code, it would be about 40. And you can see that top orange part, that's the part that's heating. So that's the portion of the energy use that's for space heating. The passive house does two things. It makes the whole energy go down. So the cooling goes down, the fan use, all that stuff goes way down. So we can easily get to EUIs of 20. So that's thing one. Thing two is that it crushes the heating use. You can see it goes from about 15, which is the size of the orange part on the left, and it goes to something less than 2 or 3. And that has huge implications for Global Warming Solutions Act, because again, it means that we can easily electrify space heating, which is kind of a really big challenge right now. Let's go to the next slide. So I just want to put this into perspective of how much we crush space heating. And the same goes for space cooling. It's the same parallel. But just to put some nerdy numbers to this, if you had a 10 by 10 room, the heating limit in passive house is 4.4 BTUs per hour per square foot. So in a room size that's 100 square feet, that would be about 129 watts. So let's get some perspective on things that make 129 watts. So let's go to the next slide. So the furnace that you have in your house, your furnace or boiler, in a typical single family house, so that might look like what you have in your basement, that is 20,000 watts. That's how much that produces. So your typical furnace boiler is literally 200 times bigger than necessary for our 10 by 10 room. So it's literally orders of magnitude too large. Next slide. So even a space heater is 15 times more heating than we need if we had our 100 square foot room built to passive house standards. Go to the next slide. So even a toaster is 10 times too much heating. So if we had our 10 by 10 room, passive house built, and we ran a toaster in it, it would get too hot. So go to the next slide. So we'll run a hairdryer, same problem. That produces about 10 times too much energy for the 10 by 10 room. Go to the next slide. Here we go. An incandescent light bulb would successfully not overheat that room. So it's about 100 watts. So just the heat from an incandescent light bulb would heat that room. So that gives you perspective of how little heating a passive house needs. And again, the same is true for cooling. So that's what I mean by it crushes the load. It makes them almost go away. All right, let's go to the next slide. So what does this mean? So these are real projects. These are pictures of 2,000 square foot plus condo units that are built here in Massachusetts. And these units are heated and cooled entirely with a very small heat pump, a single heat pump. That's it. The entire unit is one small heat pump. So that's check one. Check two, there's no perimeter heating. So you'll notice that there's no radiators along the floor at any point. There's no distributed perimeter heating along the ceilings. So all the heating and cooling comes from a single unit that's in the center of the unit. And the walls perform so well that it's perfectly comfortable to sit next to those windows in the winter or in the summer and be completely fine. There's no feeling of cold or hot. It would be served just fine with a small unit with no perimeter system. So that's what we mean by simplifying the HVAC. Let's go to the next slide. So this is another real project. This is the tech towers that Cornell just finished about a year ago in Roosevelt Island, New York. This is a 26-story tower. These are all apartments. Each one of those floors, this is an absolutely huge floor plate, is heated and cooled with a single, just two 10-ton heat pumps per floor. That's it. There's no other heating and cooling system aside from that. And the heat pump condensers are hidden. If you look at the right picture, you can see the that kind of black and white spotted fin, they call it. That is where the condenser units are housed. So you don't even see anything. So there's no like penthouse on the roof, like full of mechanical equipment. Everything becomes simplified with these small units on each floor. Next slide. Okay, so what are the implications of this for Massachusetts? As I said, when we can make our perimeter heating go way down like this and make our HVAC system get much smaller and heat things with light bulbs, that means that we can easily electrify space heating. And why is that important? Well, it's because if we look at the emissions of Massachusetts grid electricity, our grid electricity is very low. It's at less than 700 pounds per megawatt hour now. And by 2050, our grid emissions will be at 200 pounds per megawatt hour. Why is that? That's because of all the work you all are doing to put solar everywhere, to provide your support for offshore wind, hydro. All those things are going to radically reduce the emissions of our grid electricity. So that means that when we move from fossil fuels to grid electricity, we're tapping into a clean grid. This is what I call the Wayne Gretzky method. We don't want to be looking backwards. We want to look forwards and ask ourselves, what will this building that we're building today, what emissions will it have in 2050? So we want to look at the emissions of the grid then, right, and not look backwards. Next slide. Just want to put some numbers to this because this always generates questions. So here's a few numbers. What does it take to, how many emissions does it take to heat a space? This is in Massachusetts, to provide 1 MMBTU of heating to a space, okay? So in the year 2020, with our current grid emissions of about 700 pounds per megawatt hour, and when we do the math, if we're going to use natural gas, it's about 120 pounds of emissions. And if we're going to use heat pumps, it's 65 pounds of emissions, or maybe 45 if we can use ground source heat pumps. So we're already 45% less in today's world. Why don't you go to the next slide? As our emissions get cleaner, and now it's 2050, our emissions, if we go with heat pumps, are almost 90% smaller. So there's a lot of engineers and architects and consultants and everyone you could come across that work all around the nation. And it's not uncommon for them to simply use grid emissions factors that are national averages. Well, the national average grid emissions factor is double Massachusetts grid emissions. Now, if you double the grid emissions, what that means is that electrification of space heating with heat pumps increases emissions of space heating. Okay, so you can see how they come to the wrong conclusion. So make sure that when people are analyzing this stuff, they're using Massachusetts emissions, because we're actually, even today, we're already getting a benefit, and it's gonna get even better as we go into the future. So again, why does all this have to do with Passive House? Because in Passive House, it's super easy to put those heat pumps in, and it's super easy to get off gas. That's a critical thing we have to be doing. Let's go to the next slide. Oh, poll question. So let's see, in your municipality, school district, or company planning any new construction projects? Ah, oh my gosh, look at this. Yes, oh my God, 77%. This is amazing. And add to 15 thinking about it. So if you add those two, that's 90% plus, or about 90% planning new construction projects. So that's great. So here's a chance to apply Passive House. All right, let's go to the next slide. Just not seeing that
Give
slide.
me 1 second. Yeah,
Yeah.
give me 1 second.
Okay, thank you, Karen. Yeah. Again, thank you to Karen for organizing all this. Yeah, while that slide comes up, I just want to reinforce again how much we appreciate green communities participants to not only influence what they do in their town for their municipal buildings, but also influence what they, when projects come to town, whether they're private projects. We see a lot of that. So that's really important accomplishments. All right, so we talked about how Passive House can also be resilient, and what we think is a demand response asset. So this is an example of a Passive House, just as an experiment, a Passive House on Falmouth in January of 2012. The blue chart there on the chart, the blue graph, the lower line is the outside air temperature. You can see it's getting well below freezing overnight. This is over the course of January. And during this month in January, this homeowner turned their heating system off. So the heating system literally never came on for these 4 or 5 weeks in January. So even though the outside air temperature was in the freezings, you can see that the inside air temperatures that are mapped there on the top of the graph, they all stayed very warm. In fact, they're almost like hot. It's kind of funny. This goes to show how well Passive House performs. So this is a resilience thing. So if you ever had like an emergency, this is something that's going to be a good thing. But it's also a demand response thing, right? So we see these as an asset that if you had a school, hospital, apartment building, all these buildings can actually just turn off their heating systems or cooling systems during peak times and get the benefit of demand response. Let's go to the next slide. All right, everyone wants to know if it costs more. So the answer is not necessarily. So here's the data that we have a bunch of different projects we organized, looked at as-built construction costs and compared them to similar construction costs, same time, same place for similar buildings. And we observed a little trend here. So what we found is that for low and mid-rise passive house, well, let me take one step back. Single family houses, passive house is definitely 10%. It can be significantly more than code single family. So I just want to put that aside. So single family passive house can get very expensive. And that's because single family has a lot of wall and roof compared to the usable inside space. But everything else, everything larger than single family, townhouses, multifamilies, office, commercial, schools, those have very efficient envelope to floor ratios. And what we see in those cases, and they also tend to have big HVAC systems when you build them to code. So this is not single families. I should point that out. This is anything but single families. When it's low rise or mid rise, what we see is that passive house costs anywhere from $0 to $4 per square foot more. All right. And then when it's high rise, it tends to push up into the 8s and 10s. So that's kind of the pattern we see so far. Now, you might ask yourself, how is it possible that you can build a passive house for $0 more? And the answer is because you put the money into the envelope and you can actually take the money away from the HVAC. Because remember that our HVAC systems are literally multiple times smaller than the code size, and we get rid of a lot of the distribution and perimeter heating. So that just vanishes from the project. That's a zero cost. So that's how we can have $0 more. Or it might be net so that it's just $2 or $4 more, et cetera. So now that's on the cost side, right? That's the net cost side. The right side here shows the incentives. So in Massachusetts, we now have 2 incentives you can take advantage of with Passive House. One is alternative energy credits. When you electrify your space heating, you're eligible for alternative energy credits. And the second is MassSave now has a Passive House specific rebate for dwelling units in multifamilies, and it's a good amount of money. So I worked it out on a per square foot basis. So the electrification alternative energy credits, a little over $3 per square foot. The MassSave works out to a little over $360 per square foot. And this is the assumptions I'm showing here. These are 900 square foot dwelling units, say, for example. So you can see that the rebates can actually add up to can offset some or all or more than the additional net cost. So it's not necessarily more expensive. To go to the next slide. How about retrofits? We have a lot of existing buildings in our world. So can Passive House be done in a retrofit? And the answer is yes, and it's done all the time. So one approach is to retrofit from the outside. So the normal process, it's like a deep energy retrofit, the Passive House version. We would take off the siding, and you'd actually bump the windows out. You can see how those windows on that right side, they kind of stick out. So they're deliberately bumped out that way in order to receive the continuous insulation that's applied to the outside roof and walls so that it comes on the same plane. So that's one approach. Want to go to the next slide? How about if you have a historic building like this one? This one requires that you don't want to be attaching stuff to the outside of that. You may not even be allowed to do that. It just would kind of stink to wreck all the history. So a lot of you probably have buildings like this in town. This is a real project in Pennsylvania. This was a assisted living facility. And in this case, you can do Passive House from the inside. Why don't you go to the next slide? So a little hard to see. I get the idea though. On the left picture, this is applying the continuous insulation and air barriers from the inside. It really has to be a gut renovation. So it's just hard to do a historic Passive House retrofit from the inside without really totally altering the inside. When you go in from the outside, you can keep the existing inside so very much untouched. But historic renovations kind of requires you to go from the inside. So you can see on the left side how that's that continuous insulation and that air barrier is being applied. The picture on the right shows how much the wall's been built inward. So we kind of lost like 4 or 6 inches of inside space around the perimeters. And that's to accommodate the level of insulation we need and to create the right connections to the new windows. You can see the nice shelf there that's been built. Why don't you go to the next slide? Oh, there is another better picture of the window shelf in that you can see how it's been thickened. So this came out amazing. The results of this project are awesome, and we're able to keep that historic building. Let's go to the next slide. So this is another idea that is now popular in the European countries. It's pretty expensive. The numbers I showed you of passive house costs dollars per square foot in the previous slide about 3 slides ago. That's for new construction. Retrofits like I'm showing you here are probably more than that, unfortunately. So in the European countries, they've looked at doing these outside retrofits coming in from the outside, and they realized, like, this is something that's actually modular, right? So what they've done is they've mobilized panel manufacturing companies in the European countries to do these prefab panels that are made in a factory that have the walls, the doors, and the windows already built. And they arrive on site and they're simply installed around the existing building, to surround the existing building. And they do the ceilings too. And they're making passive house out of all the existing built housing with this. This is called the energy sprung approach. So there's now something like 26,000 multifamilies in Europe that have done this. And the costs now have gone way down because these factories are able to mass produce these things. So we're just seeing that start in the US. New York has a significant program in energy sprung for the US, California, and Massachusetts. We're very happy to host the first 2 projects in the Boston area that will use this approach for some existing housing. Let's go to the next slide. That's just another picture of the those panels coming from the factory and being delivered to the project. Next slide. It's maybe seems experimental. Is it new? Is it a research project? The answer is no. There's no research experimental projects going on here. There are 60,000 passive house projects worldwide. So it's been around a long time, mostly in the European countries. It's extremely understood how to do this. And there are 2 standards for passive house, Passive House Institute and PHIUS, PHIUS, which is the Passive House Institute of the US. Both of them have been in our building code for almost 10 years. So this is something that is accepted and not experimental. Next slide. This is a little picture of the passive house projects in our area. This is the Boston area here. There's a whole bunch of projects that are now being done. So this is becoming sort of normal. So that's my last slide. I do have in the deck, if you want to just advance one more slide, in the deck we included about 5 or 6 example, oh sorry, yeah. So we have 5 or 6 examples like this. We won't go through them now, but when you get the decks, you can see more detailed information about a bunch of different passive house example projects. So I'll stop there. I don't know if there's any questions that have come in through the chat or whatever format we're using.
Yes, there are. I'm going to scroll up, so just give me a second so I can try to answer them in the order they came in. Just taking me a little minute. Okay. The first question is from Luke. I won't say last names so I don't butcher anybody. They just wanted to know if this is going to be recorded, and we answered that earlier, and yes, we are. It will be posted on the website with a link to our YouTube channel, and that's where we post all the past webinars if you're interested in looking those up. Next question is from Mike, and he would like to know, could you compare and contrast other building energy certifications such as Energy Star and LEED with Passive House standards?
Oh, that's a great question. So I would say that they're mutually exclusive. Well, let's just take them one at a time. So LEED, I would say, is mutually exclusive from Passive House. So Passive House isn't a rating system. Passive House is a energy code. Passive House is, you have to achieve a certain level of energy efficiency, period. Energy use per square foot, you have to achieve a certain level of infiltration, etc. So it's a building code that's a little different than LEED. LEED is this kind of like rating system, you know, and it includes a bunch of other things that are not building energy specific. So you can have a building that's both like LEED something, LEED platinum, gold, whatever, and Passive House. I would say that LEED platinum, LEED gold, like if a building was LEED platinum, LEED gold, you know, the highest LEED rating, I would say that there's a good chance it's probably not as efficient, or it's going to use more energy than a Passive House would. So Passive House is like an EUI basis, probably still lower energy use than even the best LEED rated building, to kind of compare those two. Now, Energy Star is a little different. Energy Star is also a building code. It's not a rating per se. So Energy Star requires certain prescriptive measures, certain efficiencies. So it is like Passive House in terms of it being a code. But I would say Passive House is much higher performing, maybe by a factor of 2. So it's much better performing than Energy Star.
Okay, we had a couple questions that just wanted to know if you could apply it in a renovation, which I think you covered at the end. So I'm skipping ahead to Bob, who wanted to know, basically, is DOER working with the Massachusetts School Building Authority, as he would like to see the Passive House design phase required for these new school buildings?
Yeah, that's a good question. So the answer is yes. We're in constant conversations with the building authority, with DHCD, with all of the other state agencies to make sure that that they know about Passive House and that they start to think about making it part of their requirements. So that's a work in progress.
Along the lines of a similar question, oops, somebody's got me on non-mute. Is the energy credit, alternative energy credit, available for municipal buildings?
Yes. The alternative energy credit doesn't require you to be in a green community, doesn't require you to have mass save, applies to any building built inside Massachusetts. You can be a nonprofit, et cetera, doesn't matter. You'll still get energy credits.
Okay, and then there was a question about where they can find HVAC designers. Basically, they're having trouble finding them for attentive, responsive HVAC consultants in Mass. I don't know if we published a list of that or if the licensing agencies do.
That's a good question. So Passive House is fairly new to Massachusetts practitioners of HVAC. And so I would say there's still many HVAC practitioners that don't have any experience with Passive House. And many are working to get that experience. So if you're looking for someone to help you with Passive House that is an HVAC person, the best thing to do is actually to go to an architect that has built Passive House in the past and ask them to connect you with the MEPs, HVAC designers that they use. Because the architects would have already like done their homework. The architects that do Passive House would have already done their homework to figure out which HVAC designers are experienced in passive house, and are kind of in their stable, if you will, of sub-consultants. Yeah, I would say that there's a minority of HVAC MEP firms that are familiar with passive house and are willing to downsize their stuff the way that you can with passive house. We don't have a list. I don't think that we can kind of do that kind of thing. But if you go to Passive House Institute US website, or you go to PHI website, jump on those, and then you can search like existing passive house projects. It'll tell you all the architects and MEPs that worked on those projects. And that's the way you can connect. Then you can see if there's anyone in your area.
Okay, another question came in on the schools, basically saying the upfront cost is the biggest objection. Do we have simple payback cost avoidance assumptions and calculations with, as an example, 10-year projections? They're saying a standardized pro forma would be useful.
Yeah, we don't have anything like that, unfortunately, specific to schools. I mean, in my experience, there's simply no question that whatever the extra cost is going to pay for itself in 10, 15 years, hands down. So, I mean, that's just what we find again and again with passive house. So yes, it would be useful if we had a pro forma that we could publish that showed that. But at this point, what I recommend to teams is to make sure that you have an architect on your team that is passive house experienced. Make sure that they have a sub consultants that are also passive house experienced, and make sure they've done it before and are involving cost estimators that are also familiar with passive house, construction managers. And that way you're going to get the right answers when you ask them to go forward and price a code versus passive house, and that way you get good information. The one thing that's a pitfall, if you're like in this kind of mode of like, is it code versus something else? It's a pitfall to rely on architects and teams that are unfamiliar with passive house, and then it becomes like a little side project for them to go figure it out. I would say that they're not going to be necessarily willing to try passive house. They won't necessarily have the right experience to give you good information about how much more it's going to cost, how much more it's going to save.
Okay, and another question. Do people use these prefab panels for new builds in the U.S.?
Yes, the prefab panels that have the walls and doors in them and et cetera, and all kinds of variations thereof are routinely done even for code building. So a lot of projects that are like urban setting especially will have these panels delivered to their site, and they simply load them up onto the frame of the building. So those are the same panel, those type of panel manufacturers are repositioning to also do very high performing passive house type work too.
Okay, I'm skipping around a little bit, but we will be downloading the questions, and then we'll send them out to hopefully get them answered by Paul and his team and posting them as well. So here's another one. Is there training for contractors for new projects coming up? How does a municipality create an RFP for this work and for projects that are already underway?
So right now there is MassSave is funding lots of training in passive house. So MassSave is, I think everyone's familiar with that. That's the utilities rebate program. They all kind of collaborate to create MassSave incentives. And MassSave is making a major play in passive house. So as part of that is they identified like, wow, we need to have lots of training. We need to train everyone. We need to train owners. We need to train designers. We need to train municipalities. We need to train builders, subcontractors, cost estimators. So they are funding training all over. So the best thing to do is to reach out to MassSave and ask them to put you in touch with their scheduled trainings. And they might even be able to create a training for your group if you have enough people.
A similar question is that people are wondering, are there projects going on outside the Boston area in Western Mass, for example?
Yeah, you can definitely find passive house projects all over Massachusetts. Williams College just finished a dorm that's passive house out in Williamstown, Mass. There's many examples of single family homes that are all over Massachusetts. The past secretary of EEA, Matthew Beaton, built a passive house, his own personal house as a passive house in Shrewsbury, Mass. And there's, I know Hollis, New Hampshire is not in Mass, but that is an example of kind of being out more away from the city. That's the Montessori school. So it isn't just the Boston area doing these things.
Okay, and I guess we have time maybe for one more question, Paul. Sound good?
Sure.
Can you talk to the role of WUFI energy models?
WUFI models. So WUFI is WUFI. That is the WUFI models is the software used by Passive House Institute US and PHI. And if people are familiar with eQuest, this is another kind of modeling software. It's actually basically glorified spreadsheets that is used by Passive House designers to design the details of their passive house. And if you have a chance to get ES trained, you'll learn all about WUFI. You'll learn how to use that to design passive houses. It's really cool software. It has all of the products that that you might use for your windows, doors, and ventilators and things already built into it. It's a lot of drop-down menus, and there's now a bunch of add-ons to WUFI that allow you to use like SketchUp and integrate with AutoCAD to bring your building in and design it. So there's a lot going on there. So that's what WUFI is.
And then I guess one question, are there any concerns with air quality with the significant low infiltration rates?
Oh, that's a perfect question to end on. So the answer is resounding no. And that's because passive house projects are more ventilated than not passive house projects. So there's actually more fresh air in a passive house building than one that's not passive house building. And that's because passive house actively ventilates and recovers all the heat with energy recovery ventilation as part of its basic design elements. So not passive house, if you think about it, is kind of gross. If you build a house today, you don't necessarily have to ventilate it with active ventilation. The ventilation of your house is just the air leakage coming through your walls. So you're getting all that dust and gross stuff through your walls. That's your ventilation. The passive house doesn't do that. The passive house cuts all that off, and it takes in fresh air that's actually and also filtered, which is with very, very low MERV whatever filters. So it's more ventilated and it's cleaner air than buildings otherwise would have.
All right, as I said, we'll also be downloading these questions and sending them to our team. So hopefully we'll be able to post those within a couple of days as well. The webinar hopefully will be available by tomorrow. As they noted at the beginning, we're doing a lot of this remotely. So bear with us if things take a little longer than normal. And thank you all for coming in. And thanks especially to Joanne and Paul. Have anything else?
No, thank you, everyone. Appreciate everyone's interest and participation.
All right. Well, thanks, and stay good. Bye.
All right. Bye-bye.
Bye-bye.